Eric is a marketing analyst. He wants to start by understanding the data that is required by the Spark machine learning model. His teammate and data scientist has informed him that the model's input features are gender, marital status, profession, and age of the customer that exist in a Big SQL table based on an HDFS file. When these inputs are provided, the machine learning model predicts the product category that the customer would be interested in. Let's look at this in action. This code can be written in any open source notebook or DSX. Eric calls the syshadoop exec Spark function that is the integration point between Big SQL and Spark. He specifies the query ML model class and the location of ML model on HDFS, specifies the feature names, and provides these features via a Big SQL table, gosales.features. Let's run this. Let's look at the results. So out of our customer size of 1,000, we get 406 interested in personal accessories and the rest in other categories. Let's convert the view into table format, and we can see that each customer identified by an ID has been assigned a probability for all 4 product categories. The one with the highest probability is the label predicted for that customer. The next step is to merge the predicted labels identified by an ID with the actual customer identifying information that resides in a remote database. In this query, Eric is doing an inner join between a federated table containing customer details and the Big SQL Spark job. The power of Big SQL Spark integration can be seen in this construct where we are performing a Spark job and a SQL query inside a single Big SQL query. In the results set, we now have Anna Rodriguez with her email address and the predicted label for the product category. Now Eric wants to see the available promotions that are available today. However, these promotions are in a remote database as well. But Eric doesn't need to worry. With Big SQL's federation, a remote table will look like a local table, so Eric can query it just like a local table. Looking at the results here, there are 4 coupons available for the respective 4 product categories and their details. Next, Eric needs to map customers with actual products that belong to the product category predicted by our machine learning model. This query has 3 parts. Execute the Spark job to get predicted labels, merge it with customer information, and then map it to specific products on promotion. This is one complex query that brings in federation and Spark integration together in one single statement. Let's look at the result of the execution. In the result, we can see that Joda Doe is the customer with email address joda.doe@gmail.com, is predicted to be interested in personal accessories, and thus we map her to Patagonia Nanopuff jacket that is on 10% discount. Now we are all set to send out these promotions. Nick has created an application that can send out mass email when provided with required information. That application can be called via Big SQL as a UDF. Eric provides the required parameter for that UDF, visid, email, first name, last name, product and discount, which is the table created in the last step. Eric calls the UDF from Big SQL and provides the table that has all the columns required for all the customers. And run. The result comes back as code 200, which means OK, the execution was successful. After the execution, the customer will get an email which looks like this. This completes our demo.